Hello and welcome to the Tuesday, September 9th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Jacksonville, Florida. And this episode is brought to you by the SANS.edu Graduate Certificate Program in Industrial Control Systems Security. Today, I do want to do things a little bit different. Usually, I start with the diary of the day, but there has been a major compromise of NPM libraries. So I want to give that a little bit a more prominent position. The issue here is that, in particular, one developer, he goes in NPM under QIX or Quix, Josh Junen, has been affected by this particular compromise. And as a result, some major NPM libraries have been compromised. So, for example, the error-ex library with 47 million downloads per week, the color name with 199 million downloads per week, many other libraries sort of in the millions of downloads per week range have been compromised and have been infected, if you want to call it that way, or substituted with libraries that are including browser hijack functions. The hijacked libraries are essentially intercepting calls to XML HTTP requests and fetch. They're looking for requests that are then going to crypto coin related domains and are replacing them with sort of, again, lookalike domains, and with the goal of intercepting things like crypto coin keys and usernames, passwords, and the like. So that appears to be the main motivation behind this attack. Now, how can something like this happen to a major developer like this? Well, the problem here was yet again phishing. The email came from support@npmjs.help. The normal domain would be a .com domain, but of course the attacker owns the domain, and with that they were able to then basically send these emails without typically triggering any spam filters. The domain npmjs.help was registered relatively recently and was then used to not just get passwords from Quix, but also from other prominent and also less prominent, of course, NPM developers. And all of these accounts were compromised. It was not just the one account, just Josh's account here was the most prominent one with all the popular libraries that Josh maintains and has access to. How do you defend against this? I'm going to add the link in the show notes, a link to aikido.dev. That's one website that wrote about this particular attack. They were one of the tools that detected this. They weren't the only ones. I think Snick also published something and blocked some of these alerts. Sonatype may have done some of that. It's all still pretty new at this point when I'm recording this. But there was more than one tool that was able to detect what exactly happened here. And, so what kind of happened was fairly obvious. If you look at it, sort of obfuscated line was added to these packages. It was sort of a constant and with sort of hexadecimal variable names. So certainly something that probably should have raised people's spidey senses if you look at these the code. But of course, nobody ever can really look manually at the code. That's why these tools are important. And a new version was also released of the tool. If you lock in your versions, that sort of can help, and then more deliberately update after a particular new version has been live for a little while. And basically the community had a chance to raise alerts like this about any compromised libraries that were used here to replace existing libraries. The technique, very common. The phishing, very common with prior NPM compromises. Just in this particular case, they got more lucky by actually hitting some real big-time libraries. And well, it's not every time that when we talk about HTTP security and our honeypot that we are actually not talking about a new attack, but a new security features. For the first time now, we have seen in our honeypots requests with the HTTP request signatures headers. This is a relatively new feature, was standardized in RFC February last year, and it introduced 3 new headers: signature input, signature agent, and signature. The purpose of this particular feature is to allow the source, the client, to digitally sign part or the entire request. In what we have seen, basically just the host header is being digitally signed here, but could, for example, also include a signature for the user agent and the like. And the reason behind this is we do have TLS, of course. TLS can be used with client certificates to make sure that a request comes from an authorized client. But what this here is trying to solve here is that when you have search engines in particular and other bots spidering the internet, interacting with your web server, it can be difficult for the server to identify which bot sent a particular request. For example, with Google, Google has its user agent header, the Google bot header, but of course that's not sufficient to verify that this comes from Google. We also have to then reverse resolve the IP address and make sure it's actually a Google-owned IP address and a Google-owned IP address that it uses for its bots. With Google, that works pretty well, but of course it's not a standard and doesn't really work well with some of the smaller players in sort of search engine or now also AI agents, for example, that are starting to spider the internet more and more. So what this feature allows is it allows digital signatures for headers and also the entire request, but typically it's being limited to specific headers. What we have seen here in our example was a request that did really just sign the authority header, which is the host header, and then the signature agent header, which is the header that tells you where to get the keys from. If you want to allow specific bots to spider your site, then you can use this mechanism to make sure that this bot is actually one of these authorized bots. You don't have to rely on IP addresses. You don't have to rely on user agent headers, all of which can be tricky to figure out, in particular if you do, for example, have multiple proxies the request goes through, then the original IP address often gets lost or gets added to an untrusted header like an X-forwarded header that you shouldn't really use to identify the source of a particular request. So interesting feature, and interesting to also see that now being used in real life, even though I don't have seen really the big users using it. I've seen some notes that OpenAI is using it, which I personally haven't seen yet, but haven't also looked that closely yet at OpenAI requests. Well, and that's it for today. So thanks again for listening. Thanks for liking and thanks for recommending this podcast, and talk to you again tomorrow.